In this module, we shall be covering a very essential concept known as SQL injection. A commonly used term in the information security domain nowadays, especially in web application security, SQL injection is the process of exploiting flaws in the web application code in order to gain access to the database. It is not really concerned with database misconfiguration issues, but the faults in the input parsing mechanisms in the server-side logic lets attackers send malicious or unwanted commands or inputs to the backend of a web application. Listed in the OWASP Top 10 2013, SQL injection has consistently been one of the most notorious forms of web application attacks. The major idea here is to bypass the server tier in the web application in order to gain access to the backend. This helps to understand the security loopholes in the application. The figure shown here illustrates basic three-tier web application architecture. The tiers involve a client, a web server, and a database. The client involves a web browser which is responsible for generating requests and rendering responses for the end user. The web server receives the generated requests and via various transactions at the backend database sends the appropriate response to the client. The server contains the application logic which is responsible to process the requests and generating the responses. The backend or the database is responsible for storing application related data in an organized format. The server-side logic is usually implemented in frameworks such as PHP, JSP, ASP or ASP.NET. The transactions in the database are undertaken in SQL, so it is obvious that through SQL injection, the backend of an application is targeted and tested. Now before we delve any deeper into SQL injection, it is important for you to get an idea as to how HTTP or Hypertext Transfer Protocol works. An HTTP client sends a request using a transmission control protocol connection to a port or on a remote host. An HTTP server connected to that port waits to receive the client's message before it acts, wherein the server sends back a status line. The status line could be the requested file, an error message, or some other information. A common example of a status line is http:/1.0/404 not found, which is usually displayed to the user when they are trying to access a non-existing resource on the web application. The HTTP server then closes the connection. It is known as stateless protocol since it does not keep track of the state of the connection between the client and the server. Now HTTP requests are made using certain methods which do the underlying work of sending and receiving data, and the methods are get, head, post, put, delete, options, connect, and trace. Get method is used to request a representation of the specified resource, while head method is similar to get but without the response body. Post method submits the user data to the identified resource. Put method uploads a representation of the specified resource, and delete lets the request delete the specified resource. Option method returns the HTTP method that the server supports, while connect method is for use with a proxy that can change to being an SSL tunnel, and trace method echoes back the received request so that a client can see what intermediate servers are adding or changing in the request. Now let us get into an introduction of SQL and databases. This slide shows an example of data in a relational database. A relational database system contains one or more objects called tables. The data or information for the database is stored in these tables. Tables are uniquely identified by their names and are comprised of columns and rows. Column contain the column name, data type, and any other attributes for the column. Rows contain the records or data for the columns. Here is a sample table called users. This is a user-defined table that could be used for validating and managing application users. In this table, the first row called user ID is specified as an integer. By being defined as an integer column, the only type of data that can be stored in that column are numeric integers. User ID is also the primary key for the table. A table usually has a column or combination of columns whose values uniquely identify each row in the table. This column is called the primary key of the table and enforces the entity integrity of the table. There can be no duplicate values. The other four columns are varchar, that is variable character data. Any kind of strings can be stored in these columns. Character data consists of any combination of letters, symbols and numeric characters. To note, the password field is not encrypted. This should be implemented at an application level. These passwords are not directly linked or related to the SQL database passwords or the operating system passwords. Now we shall look into some basic SQL commands that may help to understand how transactions take place and how data is managed in the database. The queries in this slide include several variations of the select and insert statement. For retrieving information from the database, the first query is used, which involves specifying the table name where the information is kept. The where connective is used to add extra conditions in order to extract the selected information. The insert statement involves adding data into the tables in the database. In this slide, we shall see a few more SQL statements such as update and select, which involve specific operations in a database. For updating rows, you have to use an update statement with the column name and value and with certain conditions joined by the where clause. Two tables are joined by comparing specific attributes in both tables. And on top of that, SQL has inbuilt functions for certain operations, such as the count function, which finds out the number of rows in a table. Here are some other commands that are shown for several other operations. For deleting rows, the delete statement is used with conditions by the where clause and the table name. The conditions can also be modified to include specific values, which could sort out the data in a better way. Some other queries will illustrate how specific tasks are performed in the database. For specifying a pattern and querying data which matches it, the condition that should be specified here is as alike %c_t percentage where c_t denotes the pattern which is to be searched. Some keywords such as null can also be used as values in the conditions in where clause to query relevant data. Apart from this, metadata tables store information about the database. They are highly vendor specific and are denoted by reserved table names. In this slide, we shall see some basic examples on how the application sets up the SQL query in order to get the data from the client end, structure it properly and send it to the database for information retrieval. The first example shows how login function in a web application is achieved by getting the username and password from the user. In the next example, we try to bypass the password parameter by injecting a dubious entry. In this example, the same can be done for username parameter too. This is the gist of how SQL injection works by injecting false entries in login forms. We have based our methodology on the OWASP testing framework. The Open Web Application Security Project, OWASP, is a volunteer project dedicated to sharing knowledge and developing open source software that promotes a better understanding of web application security. As we can see here, there are several steps which have to be taken to test for SQL injection, such as input validation, information gathering, 1=1 attacks, extracting data, OS interaction, command prompt, and expanding influence. The first step is to find a vulnerable entry in the web application. To find vulnerabilities, all parameters in a web form must be checked. SQL injection can happen in any of the following: fields in web forms, script parameters in query strings sent as part of the URL, values stored in cookies that are sent back to the web application, values sent in hidden fields. To find all the different entry points in a web application, a web proxy or a fuzzer must be used. With a fuzzer, we insert different types of input into each entry point. Fuzzing is an automated software testing technique that generates and submits random or sequential data to various entry points of an application in an attempt to uncover security vulnerabilities. We use this technique to send specific string combinations with SQL specific reserved characters and words. We are looking for an application error or changes in the application behavior or responses due to the insertion of one or several strings. For example, the delay query will make the application respond after 10 seconds if it is vulnerable and executing our command. In this case, it would also have to be a MS SQL server. Once a vulnerable entry has been detected, the next step is to gather as much information as possible about the underlying application. The information gathering stage is fundamental. The scope and depth of the subsequent attack as well as the query syntax to be used will both be determined by the results of this stage. Output mechanisms are essential for extracting information about and within the database. Depending upon the type of mechanism found, it will strongly change the attack techniques. Understanding the underlying query will allow to craft correct statements. By knowing this, different types of error messages and attacks are possible. Different databases allow and require different SQL syntax. Defining the database engine type is fundamental for the growing stages. Different databases allow and require different SQL syntax. Defining the database engine type is fundamental for the following stages. Most advanced SQL injection requires high user privilege levels. Knowing what we can or cannot do will save us time. Finally, interacting with the underlying operating system either through command execution or through read-write access to the file system will allow a whole different group of attacks. Extracting information through error messages is a very commonly used technique used by attackers nowadays. Some known methods for such processes are grouping error and type mismatch or overflow errors. Under grouping error, within a select statement, the having command allows to further define a query based on the grouped fields. The error message will tell us which columns have not been grouped. In type mismatch, by trying to insert strings into numeric fields or a big int into an int, the error message will show us the data that could not get converted. Another method seen in SQL injection attacks is a blind injection attack. By using a condition as shown in the first example and we know the expected outcome for a correct and for an incorrect condition, we can prove if the condition is true or not. This works with all SQL databases. What varies is the type of condition we can insert. Using if statements with some kind of delay is different for various databases. Some like MS SQL Server will require the if condition to be a separate command shown in the wait for delay query above. In others, like in MS SQL, the same effect can be achieved with the benchmark function, which can be used as an expression within a select statement. Additionally, we can run the same types of queries as in normal injection but with no debugging information. This gets complicated fast. With the Boolean responses, we can extract text information by converting it into ASCII and then converting the ASCII to binary and then getting one bit at a time. This can be very time consuming and above all notorious because of its noisiness. It has been automated in tools like SQL that allow complete database structures and their contents to be transferred bit by bit. Now determining the database engine type is fundamental to continue with the injection process. Most times this will be easy if we have error messages coming back. ODBC will normally display the database type as part of the driver information when reporting an error. In those cases where the error message is not an ODBC message, that can also be useful. First, you know you are most probably not on a Windows box. By knowing what operating systems and web server we are connecting to, it is easier sometimes to deduce the possible database. Using specific characters, commands, stored procedures and syntax, we can know with much more certainty what SQL database we have injected into. In this slide are some differences that can be used to determine what database we are in if we have no other easier way. By trying out conditions using the AND condition and 1 equal to 1 statement, we can determine what type of database we have connected to. This is the architecture of what takes place in an SQL injection attack. From the web server, the web pages of an application are accessed. Then using input validation flaw in the application server logic, the backend of the application and its stored data is extracted. It is important to keep in mind that the web server in most cases is not the database server. So we might be executing commands in a server that has no direct internet connectivity. In this slide, we shall understand what evasion techniques can be applied. Both IDS and input validation circumvention are very similar. Snort-based detection of SQL injection is partially possible but relies on signatures, which can be evaded with a bit of tweaking. We will use different techniques to change the expected input and bypass completely the signatures. IDS or IPS should never be used alone to protect applications from SQL injection vulnerabilities. It should be implemented as an alerting mechanism. Input validation, IDS detection, strong database and OS hardening must be used together in order to provide comprehensive security to the backend database server. Proper mechanisms for alerts in case of such attacks prove to be crucial for timely response. Signature evasion works on a randomization of input to full pattern set in the IDS. An IDS signature may be looking for the OR 1 equal to 1. There are numerous ways of replacing this so that it continues to have the same effect. These are some of the variations that can be attempted to bypass the IDS signatures and hence should be implemented in the IDS. Input validation is the most common form of protection employed against SQL injection attacks. One common way to implement input validation in PHP is by using PHP's @s function or by turning on magic _quotes_GPC. This will protect string injection, but this may give them a false sense of security since injection in numeric fields is still possible. Some people use PHP @s function to escape characters such as single quote, double quote, backslash, and null. This can be easily evaded by using replacements for any of the previous characters in a numeric field. Sometimes JavaScript is also used for input validation, which makes evasion procedures more complex. The evasion and circumvention of security measures employed by web applications is by no means an easy task and requires a lot of time and dedication to achieve. Apart from the methods described in the previous slides, IDS and input validation can be circumvented by encoding the desired injection parameters to bypass the filters set by the web application. URL encoding, UTF-8, hex encoding, and char function are just some of the methods by which bypassing can be implemented. For security measures, input validation is the most common part of defending against SQL injection. Input validation schemes prove to be most effective in combating or warding off such attacks. You should enforce input validation in all new applications through strong design, and you should audit all your existing code and websites. You should additionally always harden your servers as well. What we believe to be a strong design is that which can be secure always. For this to happen, it also has to be the easiest way for programmers to query the database. You should use stored procedures to interact with database and call procedures through a parameterized API. All input should be validated and all database users should run under the least privilege principle. You may need to define different roles, one for every type of query. For hardening the servers, the following steps should be taken. Run database as a low privilege user account. Remove unused stored procedures and functionality or restrict access to administrators. Change permissions and remove public access to system objects. Audit password strength for all user accounts. Remove pre-authenticated linked servers. Remove unused network protocols. Firewall the server so that only trusted clients can connect to it. Typically only administrative network, web server and backup server. If there is a breach, you should be protected to the core. Never trust your input validation. Applications continue to change through time and unexpected vulnerabilities may emerge in time. Well, this will be all in this module. Following this will be a practical illustration of SQL injection to help you understand how these attacks take place in practice.
Let's start with the demonstration of SQL injection by using the tool Harvest. Let's check. Is the Harvest, right click, run as administrator. So this is the interface of the Harvest. We have to put the target in this format: http://www.target.com/index.asp !id equal to 1 to 3. Means this is the format which we have to put it in the target. Let's find out how to get the target. I'm using the Google and put my website here, and to find out whether that is vulnerable for the SQL injection or not, So I'm putting the site and find out the format. This is the format, copy this, and after copying it, paste this ID in the target. Okay, and then click to the analyze button. Now wait for the analysis. Just when this harvest will analyze, it will find out the information that whether the site is vulnerable with the SQL or not. You can see the status. It is analyzing the target. Right now it's finding the number of column, how much column which are present in this website which are vulnerable. So we can wait for the number of column, and then when the state is idle, we can find out the database. Let's see, we can find out the database. Now click on the table. So we have to find out the data from the table. Click on get database. Now the harvest will find out the database. Now it's idle. Now click on the get tables. Okay, you have to click this information schema and then click here, add get tables. Now harvest will find out the tables. Now we have to look for the tables on which table the email ID and password is there. You can see. Now stop it and I check on the table admin, because we know that it will contain the information, and click get columns. You can see the harvest will find out the IDs, username and password column. Now check it, ID, username, password and emails, and click get data. Now you can see that we will get the information, that we will get the ID, username and the password. We can use it. So by using the harvest, we can find out a lot of information. We can find out the application is vulnerable with the SQL, and we will find out the username and password, and we can use it and take the access of that website. So we can find out that this website is vulnerable with the SQL by using the tool harvest. So this is the demonstration of harvest.